So I started explaining two sample t-tests yesterday. I want to continue with that. Now, when we are talking about two samples, we have two types. First, we have paired two sample t-tests. The second one, we have independent two sample t-tests. So whenever you have to test a hypothesis and you have one variable, if it is for frequency, you use chi-square test for equality. If it is for proportion, proportion also works with frequency. If you are talking about equality, frequency equality, chi-square test for equality, that is for one variable. If you are talking about frequency proportion, you use t-test or z-test for proportion. If you are talking about mean, you then use t-test or z-test for mean. Let me go over it again. If you have data about frequency or number frequency and you want to test for equality, you use chi-square test for equality. That's for one variable. You also have another one variable, and now you're considering frequency, but your focus is on proportion. You use z-test or t-test for proportion. If your focus, one variable, but your focus is on mean, you use z-test or t-test for mean. Now we're talking about if you have two variables, and I said in our last class, two variables, we use it for comparison. You have a malaria drug and you are trying to produce yours. We already have an existing malaria drug and you want to produce yours. So you are trying to make yours to be better than the existing one. We'll add first COVID-19 vaccine, they produce more. The second one was trying to be better than the first one. So when we are talking about two variables, we are talking about comparison. We are comparing them if they are equal, if they perform similarly or not. So now, two things you ask yourself, these two variables, these two groups you want to compare, are they paired or are they independent? Now, we need to understand what we mean by are they paired or are they independent? You know, one thing I love about this, as we are doing this analysis, you also learn things that will also help you in your knowledge of statistics. So you're not just learning statistics, you're also learning things that will help in your knowledge of statistics. You're not just learning SPSS, you're learning things that also help in your knowledge of statistics. So let me explain now the difference between paired and independent. If the two variables have nothing in common, the sample points in group 1, they are different from the sample point in group 2. Take note, the sample point or observation units. We'll start explaining things now. The sample point observation unit, the subject in sample 1, if they are different from the observation unit subject in sample 2, we say they are independent. So what do I mean by observation unit or subject? These are the objects that we get the response from. So if you're talking about age of students, the students, they are our observation units because we get the age from the student. So when we talk about observation units, we're talking about the object where we get the response that we are going to use, where we get the response or data we are going to use for the analysis. We call them observation units. If I'm talking about weight of chickens, so the chickens, they are our what? Our observation unit, because the weight I want to get, I'm going to get it from the chicken. So observation units are the objects where we get our responses. Now, if the observation unit in group 1 is different from the observation unit in group 2, we say they are independent. But if the is similar to that in group 2 or can influence the one in group 2, we say they are paired. Now, let me give you practical example. Let me start with paired. Assuming before this class, I gave you this assignment, like the assignment I gave to you. Before I started teaching you the SPSS or Minitab, I gave you the assignment. And I asked you to go and do the assignment. It may be difficult for you to do because talking about those that didn't have prior knowledge of SPSS. It may be difficult for you to do. So after everything, most of you will score 0/100, 5/100, 10/100, 20/100. And after teaching you for 3 days, 5 days, I gave you the same question. And remember, the observation unit in this case, they are you guys, the students, because the score that I'm going to get is from the students. Now, I administer the same question to the student after teaching them. And after everything, they scored 80 over 100, 90 over 100, 70 over 100, 75 over 100. Now, take note. I administer the same questions to the same students. But the difference is that the first time I administered it to them, I had not taught them. They were novice. For the second time, I administered it to them. I have taught them the course. Now, I have two groups. What are the two groups? Before I taught them and after I taught them. But the observation units, they are the same because I administer the same questions to the same students in group 1 and the same students in group 2. Another example. If I have a poultry and I'm looking for a way to make my hen to grow. So I called the veterinary doctor. The veterinary doctor came. He said he has something I will give to them and they will grow. I will make money. I said, okay. But before I will give you this job, I will have to measure the weight of the hen or the chicken, or what they call them. So I measured all the weight of the chickens, the hen, whatever they call them. I measured it and I took note of them. This chicken, I wrote A on his body. Your weight is this second chicken, I wrote B on his body. And I discovered that after 5 days or after 10 days, they've received the medicine from the veterinary doctor. I measured their weight again and I recorded. In this case now, I have two groups. The weight I recorded the first time before the veterinary doctor gave them his medicine. And the weight I recorded the second time after the veterinary doctor has given them his medicine. Now I have two groups. But take note, if the same N in group 1 is also the same N in group 2. We say they are what? Paired. Very simple, paired. So I've taken my time to explain what we mean by paired. Now, if I want to use the same example to explain independence. The same example. Now, if I bought 40 chickens, 40, then the first 20, I don't want to make mistake. Okay, I bought 40 hens. The same, then 40 hens, and I divided it into two groups. The first group has 20, and the second group has 20. I bought 40 hens. The first group has 20, and the second group has 20. I allowed the first 20 to grow without giving them the medicine from the veterinary doctor. The second group, that is 20, I allowed the veterinary doctor to give them his medicine. Then after 40 days or 20 days, depending on what I'm working with, I will measure the weight of the hens that didn't receive the medicine from the veterinary doctor. And I will also measure the weight of the chickens or hens that received the medicine from the veterinary doctor. At the end of the day, I want to do analysis. I want to compare. If though there will be difference, sure, like I told you, but is the difference significant? So in this case, now we are not going to use paired. Why? Because the observation units in group 1 they are totally different from the observation units in group 2. Very simple. Now let me explain with another example. I used this class to explain. So if before I started this class, I gave you guys an assignment and all of you failed because you had prior knowledge of this course. Then another student, let's say I started training again for another student and new student entirely. But I said, okay, I'm not going to give the students the question before the program. I will teach them first before I give them the course, the question. Now, in this case, I'm not going to use paired. Why? Because the students that answer the first question and the students that answer the second question, they are totally different. The observation units are totally different. So in this case, we are talking about independence. So I've tried my best to explain paired and independence. If you have any question, you can ask. Any question, please. So no question. Then those that will watch later, so I discovered that most people prefer watching later, which is also not good for me. So I want you guys to be here also. So if you have any question, you can ask. So I've tried my best to explain what we mean by independent and paired. So if you have any question, first thing, any question on two sample tests, you have first question you ask yourself, are they paired or are they independent? So yesterday we tried to solve a question. Here's our SPSS. We tried to solve a question in this. So now we're going to do, okay. I was explaining something. Let me open a new sheet. Now, let's say I have two groups. Let me just assign random figures. Then this is the second group. This is the first group and this is the second group. So let me call the first group A and the second group B. Now, remember I told you what label is used for. If I want what I want to show in my result, I want rat is good to show my result. I will put it in label. So it will be rat is good. Then if what I want in label 2 to show, I can put Lois is a fool. Lois, please, this is an example. When you watch this video, it's just an example. So now when I do any analysis, let me just show you what I mean. If I do any analysis, what will show will not be A, for what I wrote in my label, that Lois is a fool. Please, Lois, don't come and kill me. This is an analysis. This is just an example. I can't call you a fool. So back to our training. Please let me change it for Lois will beat me. Lois is a good girl. Okay. So back to our training. So I'm just trying to explain what we mean by label. So this label must not be related to this, must not be close to this. You can write anything at all, but just know that what is the label is what will show your result. So now, we have two groups, group A and group B. So want to test. Now you ask yourself, are they independent or are they paired or are they independent? So that's what you ask yourself. In this case, now you may not know because you don't know what A means and you don't know what B means. So you may not really know if they are paired or independent. But I've told you, explained it in detail. So whenever you have any question, on T-test, you ask yourself and you'll be able to know when you read the question, you know if the observation units in group A they are the same with the observation unit in group B, you know they are paired. So I've explained that in details already. So now in SPSS, you want to do the test, but you cannot get something reasonable the way it is. I explained using Minitab. Let me open my Minitab. I explained yesterday that in Minitab will give you two options. Minitab will give you two options. So now let's talk about, we use it and let's assume that they are independent. That's what we want to solve now, independent. Minitab will give you two options and ask you, your data, are they all in one column or are they in different columns? But SPSS will not give you that option. SPSS works with only one method. What's the method? The data, they are all in one column. Take note of that. The data, they are all in one column. So if someone sends his work to you this way, first you have to arrange your data and speak in the language of SPSS. You have to arrange your data and speak in the language of SPSS. So let me show you what I mean in Minitab. This is what I mean in Minitab. So this is for group A. Why this for group B? In Minitab, if I go to start, so we're assuming that they are independent. So I'm talking about two sample tests. It will ask me, are both sample in one column? This is what SPSS understands. This is the only thing SPSS understands. But Minitab gave us option to select. So currently what we have is that they are in separate columns. I will choose this. Each sample is in its own column. Then I will select sample 1, sample 2. You go to option if you want to change your alternative hypothesis or your confidence interval. If you want graph, then you click OK. Now, what do we do in SPSS? What do we do? So you have to speak the language of SPSS. So this is how you do it. You copy this your data and put it under here. But take note where this A stops at number 7. So you take note of that. So I will put a number to identify it. 0 to represent all the numbers for A. I will use 0 to represent all the numbers for A. Then I will use 1 to represent all the numbers for B. Then you also have to, because I'm changing the data, you have to change the name. So I can put this group. Then I will come to my value. Remember, value is for coding. 0 means A. 0 is for A, group A. Then 1 is for group B. So this is how we arrange data in SPSS when you want to do t-test. I can call this, what will I call it? My data. So you change the name. So that's how it is. So remember, I told you in SPSS, you put all your data in one column. What did I do? One. You put your data in one column. Then you create another column where you will call it group or anything you want to call it. Then you code it. You know, this group now will tell you the numbers that belong to group A and the numbers that belong to group B. This is the language of SPSS. SPSS has already been programmed. So if you don't speak this language, SPSS will not understand. Let me try another example before I do the analysis. We have a data like this, and we have another data like this. Remember, I want to test the null hypothesis. So we'll call this group C. I will delete this, but I just want to explain again. Group C and group D. SPSS, you cannot do analysis like this. SPSS doesn't understand. So what will you do? You take note of where group C stopped. Group C stopped at what? 6. Group C stopped at 6. So you copy this. You copy it and paste it. Remember, group C stopped at 6. Then you come to this place and code it. It must not be 0. You code it to whatever you want. It must not be 0 and 1. You can use 1 and 2. You can use 2 and 3. Then you come to this variable view and change it. You come to value and tell it what. So if you are using 0 and 1, you come and tell them what 0 means. So 0 means C. You click add. 1 means D. If you are using 4 and 5, it won't affect your results. But just come here, you tell them 4 means C, 5 means D. You click OK. Then you change this name. You change it to group. Maybe you can change this to your data. If the data has a name, if the data they have a name, you can change it there. But if it doesn't, you leave it. So that's also, I can cancel this. No. So we have this. So remember, so we can work with this now. So you go to analyze, compare mean. So we're talking about, we're assuming they are independent, that the two groups are independent. So you click independent. Then you move your data to this place. No. Remember, because I'm changing this data, I have to delete the name of the label because it has changed. So I have to delete the name of the label. So that, because what I want to show is group and data. Analyze, compare mean, independent. I'm assuming they are independent. Then you move the data to this place. And you move your group to this place. Then here will tell you what did you use to code it. That's why I say even if you use 4 and 5 or you use 9 and 10, you get the same answer. Because you just come to this place and state it. I use 0 and 1. That's all. And if you want to change your level of significance, so if I tell you to use 99, you come here and change 99. That is 99 means 0.01. If I say use 0.10, you come 0.10 is 90. 0.05 is 95. So this is where you change it. But SPSS doesn't give you the option to change alternative hypothesis. Alternative hypothesis is always not equal to. You click continue. and okay. So this is your result. This is your result. Now, why I didn't explain this yesterday, because of what we call leaving test. Leaving test. Now, under t-test, we're talking about t-test now. Under t-test, there is an assumption. Okay, in statistics, we have many assumptions. When we talk about assumption, let me use the simplest way, one of the simplest ways, so that we can understand it. Before you can write post UTM, before you can write post UTM, you must pass JAMB. If you don't pass JAMB, you can't write post UTM. That's how it is. Before you can do the analysis, you must meet the assumption. If you don't meet the assumption, you don't do the analysis. Now, the t-test has two methods. The first method must work only when the homogeneity of variance assumption is satisfied. We are not learning statistics here, we are learning SPSS, so I can't be explaining in details what some of these things mean. But when we talk about homogeneity of variance, we are talking about constant variance of the error term. You can read more about that. Now, let me go back. So I said we have two methods in two sample t-tests for independency, for when the variables are independent of. We have two methods. The first one is that the homogeneity of variance assumption must be satisfied. While the second one is that the homogeneity of variance assumption must not be satisfied. Normally, you work first with the assumption that there is homogeneity of variance. But if you discover that the assumption is not satisfied, that you can't use that method again. You go back to the method that allows you to solve when the homogeneity of variance assumption is not satisfied. So now let's look at this. Now look at what you have here. Look at what you have here. Look at the first answer. Look at the second answer. You're not supposed to report. You're not supposed to interpret both answers. You're not. SPSS will give you so that you will choose. You're not supposed to interpret both answers. The rule is that first, try to work with the first method where the homogeneity of variance assumption is satisfied. Try to work with it. That's what you work with. So looking at this, you work with this first one. What I mean is you work with this first one, you delete the second one. You delete the second one. And work with only the first one. You delete the second one and only work with the first one. That's what I mean. But if you discover that the homogeneity of variance assumption is not satisfied, you delete the first one and work with the second one. Very simple. Don't disturb yourself. So how do we test if the homogeneity of variance assumption is satisfied or not? How do we test if the homogeneity of variance assumption is satisfied or not? So this is how we test it. We use the leaving test for equality of variance for it. We use the leaving test for equality of variance for it. Okay, sorry for the break in transmission. So we can continue now. So like I said, so let's check if the equal variance assumption is satisfied. It is satisfied when the p-value is greater than your level of significance. So let's go back to our 0.05. So because we are using 0.05, look at the 0.05. We selected 95. 0.05, and in this case our p-value, sig here means significance level, which is our p-value, significance of the test, which is our p-value. The significance of this test, the p-value, is less than 0.05. So because it is less than 0.05, we say the equal variance assumption is not satisfied. Please let me say it again so you understand it. Equal variance assumption is satisfied when the p-value of the leaving test is greater than your level of significance. Equal variance assumption is satisfied when your p-value of the leaving test is greater than your level of significance. But that's not what we have here. So because that's not what we have here, we can't continue with this. So we have to repeat this. Compare. We have to repeat this. Then delete the first one. So it means we are going to delete this first one. That's what it means. That's it. Remember, the first time I deleted the second one, I told you won't report both, you report only one. You check if, first of all, start with the equal variance assumption, if it is satisfied or not. If it is not satisfied, you delete the first one and go with the second one. Yeah, you don't need to test for any assumption because you are already telling them that equal variances are not assumed. Mary, you are joining us today. That's great. So let's continue. So in this case, normally I used to delete some of these things. I've told you don't report everything. So I used to delete these two. I used to delete these two. I leave only this. Even if I want to report this, I don't report everything. I delete some. So I can leave this, because they are very important for the living test. I leave this and this. But I delete this. Sometimes I even delete confidence interval. Sometimes I delete it. I delete this 95 sometimes. Depends on how I feel. It's your choice. Merit, you're welcome. Okay, she's a local girl. She doesn't know how to connect our audio. So let's continue. So in this case now, Santos, are we going to reject the hypothesis or not? Santos, are you with me?
Yes, sir. Right on, sir.
Are we going to reject the hypothesis or not?
Sir, which one? Which one in particular?
This one. Are we going to reject the hypothesis?
Which level of significance are we using?
0.05. 0.05.
0.05.
Mm.
Since it is less than 0.05,
We are going to reject. Simple.
get it.
So we are going to reject. Now, so what we are rejecting is that, look at what we are rejecting. We are rejecting that these two groups, A and B, they are not the same. Now, if I want to interpret this work, okay, let me just do a little interpretation again, which I don't want to do. Let me do something. So I normally use Times New Roman 12 this 1.5. So we are going to test the null hypothesis again, that group A. Santos, you can mute.
Okay, sir.
Okay, I think it's from Merit. Local girl. Merit, how are you doing? I'm going to test the null hypothesis that group A is not different from group B. Merit, how are you doing? Against the alternative hypothesis that group A is different from group B. This what I wrote now. So another person can say, no, I don't like what this man is writing. So you can write it this way. We are going to test or I say we have two groups, A and B. We want to test if they are significantly This word I'm supposed to put it here. I'm supposed to put it here. It's very important. Significantly different from it. Again, that A is significantly. So let's go back. So this statement I wrote, another person can write it this way. Like I told you, there is no pattern. We have two groups A and B. We want to test if they are significantly different from each other. The following hypothesis will be used. So the person can write it hypothesis. Plural of hypothesis is SPSS. So the person will write it this way. Insert object Microsoft equation. Microsoft equation. There's no Microsoft equation here. Ah, that's bad. There's no Microsoft equation. So I can write it this way. H. Normally we use Microsoft equation to write all this. Group A copy this H1. Now these two statements are the same, just your choice. You can decide to write it this way. Both of them are saying the same thing. So if you want to write it this way, you write it. If you want to write it this way, you write it. So let me continue with this. The level of significance for this test is 0.0. Selected or chosen for this test is this. Merit. Unmute yourself.
Yes, good evening.
Good evening. How are you doing?
I'm fine.
Sorry for calling you a local girl.
Did you?
Yes, I did. And you know, this we are
Hey,
recording it. We are recording it. So everybody will know that you are a local girl. Sorry for saying that. Sorry for telling them the truth.
you have started. Better be teaching.
Okay, well, let me
Should have
focus.
been quiet.
Let me focus. Let me focus. You are welcome.
Focus. No. Thank you.
So the level of significance choosing for this test is 0.05. Another person can decide to write it like this. Insert. My system, normally we use object. My system doesn't have it. I'll correct that. So because it doesn't have it, we use this. You go to symbol, you use alpha. And undo it. Equals to 0.05. So this, I can write it either this way or write it either this way. They mean the same thing. Your choice. But I'm still following the rule. What's the rule? State your null hypothesis, state your alternative hypothesis, state your level of significance. Then state the test statistics we are using. So the two sample independent t-tests will be used or is used for this study. Then you can tell them the reason why you are using it. Because the two groups are independent and we are concerned in testing for the significant differences. So I've stated the test statistic and the reason why I I selected it while I'm using it. Then you copy your result from SPSS. You copy your result. You can copy this and this. Copy and move. No. Copy this. Copy this. What am I doing? Okay. Remember, I told you I don't like my table being this way, so I normally no border. Then I arrange it the way I want. This is how I arrange my list. I will do the same thing to this. I will remove the border. There's no border. Then I will highlight. I won't be doing this always. I'm just this second time I'm interpreting. So after now, I don't think I will repeat it. Top. So I'll put top here. Top. So I think I'll put top. Or this is bottom. 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 Okay, it's nothing. So that's all. So I'll put top here. Top. So that's all. So it depends on your choice. You do it the way you want. So your choice. So you have to interpret. Remember, I told you don't just copy table and paste. You also have to interpret it. So I can put the descriptive statistics for the two groups are given in table 1. Then you also have to maybe you explain what we have there. So both groups have 7 observation units or 7 sample points or 7 samples, depending on what you want, with a mean of 6 points, with a mean and standard deviation of 6.29 and 2.498 respectively for group A then you write for group B. So that's all. Then you continue that way. You come to this place and interpret you make your decision. We are going to reject or we are not going to reject. So in this case, we are rejecting. Why are we rejecting? The p-value is less than the level of significance. So you reject and make a conclusion. What's your conclusion? That group A is significantly different from group B. So that's all. I will stop here. So we are done with t-test, 2 sample t-tests for independence. So if you want to do the same thing in Minitab, how do you do it? So we have 2 groups. Minitab will give you 2 options. Arrange them in 2 groups like this, or you arrange them the way they arrange it in SPSS. So you come to statistics, basic statistics. You come to 2 sample t-tests, not paired. 2 sample t-tests is for the independent 2 sample t-test. I've explained it, so those that came late can check the early part of today's class. So you choose what you want. This first one is how SPSS data are arranged. The second one is that both of them are in different groups, which is what we want. You select, you move A, you select, you move B. Then you go to option to select if you want to change your level of significance. Minitab will give you option to select your alternative hypothesis. SPSS doesn't. So you want to ask a question, what if the alternative hypothesis I want to use is less than? What will I do? This is the question. What if the alternative hypothesis I want to use is less than? What will I do? What will you do? Very simple. Come back to your results in SPSS. Divide your p-value by 2. Once you divide it by 2, it becomes either less than or greater than. Once you divide it by 2, it becomes, depending on what you are solving, the data, it becomes either less than or greater than in the alternative hypothesis. So just divide your p-value by 2. So that's how to move from not equal to either less than or not equal to either greater than. You divide the p-value by 2. You can try that yourself. Take the same data, move to do it in SPSS, divide by 2, then go to Minitab, change it to less than, and see what it will give to you. So I've been able to show you how to do 2 sample t-tests using both Minitab and SPSS, and I've also tried to show you how to interpret using different ways. You can do it this way, another person can write it this way. Both of you are correct. So let me talk about paired sample, then we'll stop for today. So I've explained what when we use paired sample, sample t-test. So now let's assume that this data, group A and group B, they are for paired sample. They are for paired sample. What do we do? For paired sample, you can't arrange your data this way. You can't arrange your data this way for paired sample. You can't arrange your data this way for paired sample. Your data has to be this way. You copy this. You have to arrange it the way it was before. So group A, group B. So for paired sample, you arrange your data this way. For paired sample, you arrange your data this way. So you go to analyze, compare me, paired sample. It will ask you what's the first group you choose. You click. You can use your arrow. If you want to use your arrow, you click here. Then you click here and use your arrow. Then to go to the other side, you click here, use your arrow. Reset. You can also drag it this way or move it this way, the one you want. I've already explained when we use paired. So you check those that came late can check the previous explanation that I did in today's class. Option, you select your level of significance, you can change it. That's all. So the interpretation is also the same. But take note, for paired sample, there is no homogeneity of variance assumption. For paired sample, there is no homogeneity of variance assumption. I told you that for independent sample t-test, we have homogeneity of variance. So if the homogeneity of variance assumption is satisfied, we use the first result. If the homogeneity of variance assumption is not satisfied, we use the second result. But don't ever interpret both results. Don't try that. So use only one, depending on if the homogeneity of variance assumption is satisfied. For paired sample t-test, we don't assume homogeneity of variance. Like it doesn't come out with the result like we've seen. So I told you I don't like reporting this. I used to delete it. Sometimes I delete the confidence interval. Depends. Sometimes I won't delete. So it depends on what you want. So you interpret it the same way. So in this case, the p-value is also less than our level of significance. So we are going to reject. So the same thing. So I'm going to, if you want to do it in Minitab, you go to start, basic statistics, paired. The same way in SPSS, you move group A, group B. You change your level of significance. Remember, I told you, Minitab always give you option to change alternative hypothesis. If you want to change alternative hypothesis in SPSS, you divide by 2. Okay. If you want graph, you click this. SPSS didn't give us option to select graph. As I say, sometimes Minitab will give you some things that SPSS will not give you. And then sometimes SPSS will give you some things that Minitab will not give you. Minitab now gave us opportunity to plug that. SPSS didn't give us. So you click OK. So this is it. I'm not using the same data, so that's why I'm not going to get the same result. I'm not using the same data. I'm not using the same data in Minitab and SPSS. But if you use the same data, you get the same result. So that's it. I've taught you how to interpret. One thing about one of the disadvantages of Minitab is that the result doesn't come out as stable. So if this result I've already explained in yesterday's class, this result, so if you want to convert it to table, what will you do? You copy it, take it to Excel. When you copy it, you take it to Excel, you paste it. You paste it. It will not paste as table. You go to data. You go to text to column. It has fixed width. It has delimited. Fixed width, you don't select anything that comes out. Is what you will see. This is fixed width. It will assist you to put lines, put borders. So let me check delimited. Delimited will ask you, how do you want us to create order? To create the border? You want us to use space? If you use space, this is how it will come out. There is no comma. So let me use space. The same thing as. Remember this one, you copy it, you arrange it to ensure that that's what you copied. So you move it to this. So that's it. You can now put your border, top, bottom. You put your border. So this is how to move Minitab to convert the result from of Minitab to table. Because most times if you copy the result that way, they will return the work for. I've done that most times when I'm tired. I just copy the work from Minitab and send and paste it in Word. Most times they used to come back with it that I should put it in a table. I seen it. It's in tabular form now. If you want to arrange it, you click this. Remember, I've taught you go to layout, you align it, make your work neat. So you make your work neat. So I think we've succeeded in explaining t-test today. So in our next class, we'll talk about ANOVA. So that will be on Friday. So on Friday, we'll talk about ANOVA. We'll talk about ANOVA, we'll go to the next thing. Talk about ANOVA. So we're going to stop here. So when I will explain what we use ANOVA for in our next class. So well, let me just give you a brief introduction to ANOVA. In t-test, we only do t-test for one sample or for two samples. So in a case when we have more than two samples, we don't use t-test. What do we use? We use ANOVA. For example, if we already have two existing COVID-19 vaccines and you want to produce yours, but you want yours to be better than the first and the second one, you can't use t-test because you are not comparing just two. So what do you use? You use ANOVA. So that's all for today. Do you have any question? Santos, do you have any question?
No, sir.
Mary, do you have any question?
No.
Mary is the intelligent girl. She's not local, please.
Sir, I be a student in statistics.
Santos, you like women too much. You've seen a lady now, you're asking if she's a student in statistics. Santos, let me end the training. Let me stop recording.